Hi students, welcome to this new video on inverse of a matrix. In previous videos, we showed you how to find the determinant of a matrix and the adjoint of a matrix. In this video, we have to combine those two properties in order to find the inverse of a matrix. If a matrix A is invertible, then the inverse A minus 1 can be written as follows: 1 over the determinant of A times adjoint of A. Now, this equation 1 exists if and only if the determinant of A is non-zero. Now, can you remember how we define the determinant of a matrix? Let's have a look. We said previously that the determinant of a matrix equals to sum when G goes to from 1 to n of AIG, CIG, where AIG are the element of matrix A and CIG are the element of cofactor of matrix A. So this determinant, this expression is done by the ith row expansion of A, right? And we also say that the cofactor matrix is equal to minus 1 I plus G, I power minus 1 power I plus G. I is a row and G is a column of the element of the matrix, and then times MIG, where MIG is the minor matrix of A. Now, so to therefore find the inverse of the matrix, we need to make use of these three properties or these three notions, which are the cofactor, right, the determinant, and finally the adjoint. Now, let's have a look on this example together. Example: find the inverse of A, where A is 1, 2, 1, 2, 3, 2, 1, 5, 0. So, we need to first find the determinant of A. And if we need to find the determinant of A as a solution, to find the determinant of A, we need to make use of this formula, equation 2, and even this equation 3. Okay, so it means that we need to find the minus of A because the determinant is expressed in terms of cofactor, and cofactor is expressed in terms of minor. So, in our attempt to find the determinant of A, which is written as right, we need to find the minor of A because this is the expression of the cofactor. We already know the element of A. So if we want to find the minor, let's remember that we have what we call the place sign, which is this, right, for a 3 times 3 matrix. So if I want to find the minor of the first element here, M11, which is if I do this, it means that only so if I do this, right, it means that I will have 3, 2, 5, 0, which equals to minus 10. If I find 1, minor of 1, 2, this element, so if I do this and this, I'll be left with 2, 1, 5, 0, which equals to minus 5. If I find the minor of 1, 3, this one, and I do this, I'll be left with 2, 1, 3, 2, equal to 4 minus 3, which equals to 1. So you see that we can also easily find also the minor of 2, 1, this term. So I do this and this, I'll be left with 2, 2, 1, 0, which is 0 minus 2. And the minor of 2, 2, this term here, so I do this I'll be left with 1, 1, 1, 0 equals to minus 1, right? And then you can see that if I want to find the minor of this element here, right, and doing that, I'll be left with the minor of 2, 3, right? I'll be left with 1, 1, 1, 1, and 2, 2, which is 0. And then you can do the same to find the minor, right, from the last row, the element of the last row, minor 3, 1, right? If you do the same proceeding that we did, observing the matrix this term, you will have 7, okay? And minus 3, 2 will be this term here. You will have 3, okay? And minus 3, 3, which is this term here, which will give you minus 1. Okay, having all these elements of the minor, we can build, therefore, our minor matrix, which is minus 10, minus 5, 1, right? Minus 10, minus 5, 1. Then we have minus 2, minus 1, 0, 7, 3, minus 1, right? So then, this is a minor matrix. This is my place sign, eh? I put it back here just to call your attention on that. So if I want to find, therefore, the cofactor matrix, right, which is equal to what? Remember, we say that that cofactor equals to minus 1 I plus G times MIG, right? So this expression is the same as applying multiplying this term here, minus 10, times its corresponding place sign. So minus 10 times the positive sign, it remains minus 10. Minus 5 times the negative sign is 5. 1 times plus is 1. Minus 2 times minus is 2. Minus 1 times positive minus 1 and 0. Yes. And then we have 7, minus 3, and minus 1. So this is my cofactor matrix. Then I can have the adjoint now. I know that the adjoint matrix of A is equal to the transpose of the cofactor matrix, which will equal to minus 10, 5, 1. Now the row becomes the column, right? So I have, yes, and I have 2 minus 1, 0, and I have 7 minus 3 minus 1. So this is the adjoint of my matrix, right? Then if I then want to find the inverse, which is equal to 1 over the determinant of A times the adjoint of A, one thing is lacking is the determinant. So to find the determinant, what do you think I will do? Determinant, therefore, will be the element of A. Remember that it is A, right? And then we also got we have 1, 2, 1, and then we have we got here we got 5. So let's see. You see that determinant. Let's apply determinant equals to sum aij times c. Okay, so my determinant of A, therefore, right, will be 1 times minus 10, right, plus 2 times 5 plus 1 times 1, which equals to 1. So the determinant of A is 1. Therefore, I can have that the inverse is 1 over 1 times the adjoint of A, which is simply equal to the adjoint, right, which is given by minus 10, 2, 7, 5, minus 1, minus 3, 1, 0, minus 1. So this is the inverse of matrix A. I believe that you got the main idea on how to find the inverse of the matrix. And then by rewatching this video and doing this example and many others, you will understand and grasp how to find the inverse of the matrix. Thank you.